Factor completely 108x to the 3k minus 32y to the 3k. At our first glance, it might seem that 3k is a common factor, but actually that's the exponent indicating how many x's we have and how many y's we have. So if we're going to try and factor out the greatest common factor, we'll look at the coefficients and note that 4 will go into both of them evenly. With one set of parentheses, I'll show you what's left. 4 goes into 108 27 times, x to the 3k minus 8 y to the 3k. This appears to be the difference of perfect cubes. Let's make sure everyone has a cube so that we can factor this correctly. 27 is 3 cubed. X to the k is being raised to the third. Minus 2 to the third is 8. Y to the k is being raised to the third. So now if we want to continue factoring, we will write what we see without exponent 3. 3x to the k minus 2y to the k. Now in that second set of parentheses, we have to write in the first term squared, 9x to the 2k, and then multiply the two terms together, which would give us a 6x to the k, y to the k. And then we square the last term, and that would give us a 4y to the 2k. Checking our signs, the last one's always a plus, and the other one's the opposite of what we started with. We started with subtraction, so this is addition. And there we have that problem factored completely. In the next example here, you notice that we have negative exponents. Negative exponents is nothing more than a reciprocal. This is 1 over x plus 4 over x squared plus 3 over x cubed. So if we want to factor this, maybe it'd be nice if we started with a common denominator. If we multiply this first term by x squared, both top and bottom, so that we don't change the problem, and the second term by x, both in the numerator and the denominator. And this last term already has an x cubed, so now all the denominators are x cubed. I can factor out that x cubed and then show you what's left. We have x squared plus 4x plus 3. So this common factor we took out of each term will continue to be in the front as our leading factor, and then we'll, in two sets of parentheses, factor this trinomial. Breaking down x squared, we'll put an x in the front of both parentheses. Breaking down 3, well, that's 1 times 3. Checking the sign, since the last one is a plus, it means that they are the same. We look here to see what they're going to be, and they're both going to be pluses. Now recall, x to the third in the denominator is the same thing as x to the negative 3 times x plus 1 times x plus 3. So essentially what we've done is we looked at the original expression and we saw the highest negative exponent and factored that out of everything. The easiest way to do that without making mistakes is to write it as fractions and get your common denominator and factor that denominator out.